Welcome back to Gophercises. In this exercise, we're going to be building a sitemap builder. So the primary goal here is to build a program that will use the link parser that we created in the last exercise. And it's going to use that to basically go to a website, get all the links on that website, and then follow all those links and basically try to figure out all the different pages that exist for a specific domain. So for example, if we were going to my blog, calhoun.io, you might start here and the first link it might click is one of these blogs. So maybe it goes here and it says, all right, we've got, this is one of the pages. Well, then it might find this all articles link up top and click it, and then it would realize, oh, this is a page we've already seen. So we don't need to do that again. It might go to the About Me page and look at all the links here. But it's basically going to try to follow all the links on a website and try to make a list of here are all the different pages on that site. Now, where this is useful is whenever you are submitting your website to a search engine or something like that. Oftentimes you'll provide a sitemap to guarantee that it finds all the pages. And this can be especially useful if you have pages that aren't linked, like that aren't easily to get to through links, but they still are part of your page. Especially if you go to your root page like calhoun.io and you do have a link that you can't get to just by clicking links, you have to actually type it in or something and you want it to be in Google search, you might put it in your sitemap. What we're going to be doing though is just focusing on the links that you can get to by clicking. So if you go to just the base domain of calhoun.io, we're going to find every single page underneath that domain that you can get to by clicking. Whenever you do create this, the goal is to get it in this format of this XML here that I've got shown. The first part, it doesn't have to be exactly this, I don't think. Basically, we're going to want a header, an XML header. And whenever we finally get to the XML package, I think it has a header constant that you can use. So that's what you're going to want to use here. The rest of this is what we're actually going to be setting up though. Basically what's going to happen is you're going to want to create this XML section, and each URL is going to be a little block like this. And inside of it, it's going to have a location, which is a single page in your website. Now, there are other things you can do with the sitemap protocol. You can say things like how often that page refreshes, things like that. We're not going to focus on that. We're just going to focus on getting all the pages right now. And if you want to add that sort of thing later, you can. The way this is going to work, just a rough ballpark or a rundown of what I would suggest at least, is you're going to want to use the link package we created before. I think I mentioned that, but you're going to use that link parser that we created in a previous exercise. And you're going to use that to take a response body. Whenever you make a request to get a page, you're going to get a response body, and you're going to pass that into the link parser and parse all the links out. Once you get the links for a page, you're going to have to figure out which links go to a page on the same domain. So when you're creating the sitemap, you only want pages that are on the same domain. There's basically two ways that I'm going to suggest you focus on it first. The first are links that just have a slash at the start. So I have this right here. You've got just slash, so this is just a path link. It's just giving you follow this path. The second is links that start with like HTTPS. So those are going to be ones that specify the domain already, so you don't have to do anything special with them. So when the ones with the path, you might have to do some work to add the domain to them so that it's the same domain. Whereas these ones, you won't have to do as much work because they're already set up for you. Now, you might find links that have other formats. For example, you might find mail to links. You might find fragment links, things like that. I would just skip those for the time being. You can go back later and try to add some, more, make your sitemap builder a little more robust. But to just get it up and working and just sort of get an idea for how this works and to, just learn how all these different packages work, I think this is plenty. I don't want to get into the nitty-gritty details of trying to get every small minor piece working perfectly, because that can take a while to get completely right. But just getting something that works with the basics will teach you how these packages work and give you a good idea of, good understanding of them. I think that's roughly everything that you're going to need. I will say that as far as exploring the page goes, I'm going to sort of leave that up to you right now. In the videos, I will eventually show you how I plan on doing it. What sort of algorithm I'm planning on using to go traverse all the pages and avoid things like cycles. And, eventually I think it's a bonus exercise. Let me see. Yeah, it is. Eventually you might want to add something like don't go more than 3 links deep or 4 links deep or whatever you want to say. So, only sitemap the pages that you can reach within 3 links. And that can be tricky at times because some pages, it depends on the route you take to get there. I think I have an example of this, down here. If you have a page where you have to click from page A to page B to C to D, in that specific order, it's the only way the links are, then D takes more than 3 clicks to get there. But if you had something where you can go A, B, C, D, or you can go straight from B to D, well, then you can get to D in 3 clicks by going A, B, D. So, you will have to make sure you take that sort of thing into consideration whenever you do the bonus part. 2 other notes that are worth mentioning. One is that cyclical links are very, very likely. It's very common for a page to have a nav bar that links to, the about page, the home page, maybe a pricing page, and every page will have it, so you'll have cycles. Keep that in mind, and remember that these cycles could be any length. It might not just be home links to about and about links to home. It might be, a longer cycle, but it could still be a cycle. So you need to keep that into consideration, or take that into consideration, and you need to make sure that you don't try to hit the same page many, many times. If you do it correctly, you should be able to limit it so you're only hitting every page once. That's assuming that there's not redirects or anything funny like that. So that's another thing that makes this sort of thing a little bit different. The next thing is packages that are going to be useful. So when you go to do this, there's probably more packages that you're going to use than what I'm listing here, but I'm just going to tell you the ones that I'm pretty sure you're going to be using. I haven't coded this, so I can't say for sure. But I'm pretty sure you're going to be using the net HTTP. So this is what you're going to use to send outgoing web requests and to get pages. You're probably going to want to use that link package that we created before. You might be able to find something else online and use it. It's kind of up to you, but I would definitely suggest just using the one you created because it kind of lets you test what you used. And also it's like that, that sense of satisfaction that you use something you created to make something even bigger. If you haven't done this and you really just want to grab the code, you can get the branch, the solution branch from the GitHub repo. You can't just go get it because I don't have the actual working code on the master branch. And we'll just grab the master branch. So make sure you actually, check it out yourself, clone the repo yourself, put it into your Go path, and check out the solution branch, and then it should work from there. Oh, and if you don't know how to do that, just go ahead and send me an email. I'm happy to help out, that sort of thing. The next package you're going to want is encoding XML. So this is a package in the standard library that is used to encode things into XML format. It's going to make your life a whole lot easier when it comes time to build that XML document. You could try to do something with maybe a template, something like that, but I wouldn't recommend it. There's all sorts of ways you could get that wrong, and it's just not worth screwing around with yourself. It's easier just to use the encoding XML package. And then I have the flag package here. I'm going to suggest just using flags. You have to get the URL that the user wants you to build a sitemap for. I think I mentioned that up here. And if any of this is fuzzy, I definitely recommend reading this whole exercise detail section first. It usually goes in a little more detail than what I'm saying here. But whenever you're trying to get the URL that you're going to go to, and when you do the bonus part, if you're trying to get the depth portion, it's easier just to put these two as flags right now. There are other ways to take it in, like an argument that's just sort of passed in the command line whenever you call the binary, and you could do something like that, but it's probably just easier to use a flag because we've seen how they work in other exercises. And usually if I'm building a command line application, I will use a third-party tool like Cobra, which I can show you real quick. It's actually F13 Cobra. So, you might use a tool like this, which makes it easier to build sort of command line applications. And this is, it's a third-party application. It's a little bit more than what you might want for a 50-line program, or, this is going to be more than 50 lines, but, a couple hundred lines of code. But if you're building like a more robust command line program, something like this might be helpful. But in this case, since it's not going to be anything too crazy, I think using flags is fine. And yeah, as I said, there's probably more packages. Don't worry if you're importing other ones. You're probably going to import a good bit, especially standard library packages. That's cool. Just try to get something up and running. Before we get to coding, I want to take a moment and just talk about the strategy we're going to use to solve this problem. I think a lot of the times when you tackle a harder problem, it's easy to jump right into the code. But realistically, the best thing to do for a lot of people, including myself, is to take a step back and just think about what's the high-level approach I'm going to be taking to solve this problem. Because if you can explain that to somebody and just, really just give them an idea of like, all right, first I'm going to go here, I'm going to do this, I'm going to make a list of these things, I'm going to filter these things, steps like that, it becomes much easier to then code it because all the coding process is taking your, the algorithm you've sort of thought up in your head and translating it into code that can run. Whereas if you're trying to write the code and come up with the algorithm at the same time, sometimes it's just a little bit too much and it makes it, it's easy to get details mixed up or missed and things like that. So what we're going to be doing in this sitemap builder is we're going to be trying to get all the links from a website that are also on that same domain. So to sort of give you an idea of how this works, I've created a tree here that represents a website. Now it's a fake website. It's sort of reminiscent of my blog, but not quite. And the idea here is that I'm just going to give you, a rundown of what these links are, how they're represented in this graph, and then I'm just going to show you visually what we're going to be doing with our strategy. So the first is this, the top part is the root page, the home page that we're going to be going to. So I'm putting just slash here, meaning like the root domain, the root part of the domain. But this could be something like calhoun.io, gophercises.com. It's just the root page, the first page we're going to start with. So from there, I have lines coming under it, and each of these lines represents a link. So from this page, it's got 4 different links. It's got page 2, Let's Learn Algorithms, Hire Me, which is really my blog or about me page on my blog. It's a long story. And then there's a link, maybe there's a link to a GitHub page. So we've got all these links, and then on each of these pages, there's going to be links coming off of them. So page 2 might have a link to closures, an article on cookies, one on SQL injection, one on graph theory, one on bubble sort. So we've got all these different links that are coming off these different pages. So the approach that we're going to be taking is, there's really 2 parts. I say 2 parts. We want to know what we're doing when we get to each individual page, and we want to know what we're doing at a higher level to figure out what all the pages we need are. So first, for an individual page, we're going to start here at this root page. Every time we go to a page, what I'm planning on doing in my code is getting the page. So I'm going to use the net HTTP package to actually go make a web request and get the HTML for that page. Once I get the HTML, I'm going to use the link package that we created in a previous exercise, and I'm going to use that to parse out all the links. So I'm going to get all these things down below. Once I get the links, a lot of these links could be path specific, things like that. So I'm going to go through those links and I'm going to try to clean them up. I'm going to try to add a domain to links that don't have a domain. I'm going to, I guess that's pretty much just the first step. Just add the domain to any links that don't have the domain that need them added. After that, I'm going to come through all those links again, and I'm going to try to filter out the ones that I don't think are relevant to us. So if it's a mail to link, if it's a link to a different domain like this GitHub one, I'm going to filter it out. And then once I've done all of that, I'm going to have a list of, just links that go to other pages on the same domain. So basically, other pages we want to include in our sitemap. Once I have that list, what I'm going to do is I'm going to store it somewhere so that I know, all right, here's all the pages that this homepage links to. And I know that we need to go visit all those pages to see what links they have. So I'm going to go ahead and circle it. I've got a list of links like this, and I've filtered out the GitHub one. So with this, I'm going to have a list, and I'm going to say, all right, now that I've done the one page, I've got this list of new pages to get. So from there, I'm going to go through every page in my list, and I'm going to find all of the links that they point to. So from page 2, I'm going to find all of these links. Doing the exact same thing I described up here for the slash, for the root page. And then from the Let's Learn Algorithms, I'm going to do the same thing here with something like this. But instead of putting it in my original list, this blue list, what I'm going to do as I go through here is I'm going to create a new list that is going to include all of these. So I know it's kind of hard to see this. I should have drawn this a little bit different. But everything down here below, it's going to include all of those. So as I go through every single page in my first list, I'm going to add all the results from every single page to a new list. So that's going to be this list here. And then I'm going to repeat this process. I'm going to take this new list that I created, and I'm going to go through every page on it, and I'm going to create another list that has all the links from those pages. And as you do this, you'll see that you're basically going through each layer of this tree, one layer at a time, getting all the pages from it, and creating a new set of all the links that are on the next layer. Some other things that we'll also have to keep into consideration as we write our code is we don't want to visit the same page twice. So there might be links, there might be loops. You might have something where the root page links to page 2, and then maybe on page 2 it links to page 3, and then maybe from page 3 it links back to page 2. So you don't really need to keep that. You don't want to go visit the same pages over and over again. And for our sitemap builder, really, we don't need to store it twice. So we definitely won't have to keep links that we've already seen. So that's something you'll have to keep into consideration, or take into consideration. But that's, at a high level, that's what we're looking to do. We're looking to go through every single layer of our tree, look at all the links on that layer that are relevant to our sitemap builder, and then find all the links from those pages. And what I've described to you is basically a BFS. I mean, it is, but the way I've described it is not generic enough to be a BFS. So a BFS is a breadth first search, and it's a graph theory algorithm. And in this case with the tree, it's very good at sort of exploring the entire tree one layer at a time. And that's why they say breadth first, because you're spreading out as you go. So you start at the very root, you spread out to every link from it, and then you spread out to every link from it in the next step, and it keeps on spreading out. Now, the upside to this approach is, we'll see pages as quickly as we can. So if you wanted to know the minimum number of clicks to get from the root page to another page, you could actually keep track of that. Along with that, you could also set a max depth of, like I said in the bonus exercises, if you don't want to go more than 3 or 4 links deep, this will allow you to sort of make sure you hit all the pages you need to hit while, not worrying too much about missing other pages. So I know that might be a little confusing. I hope to eventually do a more algorithm-focused series. I have a couple videos and stuff like that on my blog that talk on some of these, but it's not really a dedicated series just yet. I want to do something like Gophercises with algorithms at some point, but that'll have to wait till later. I'm already swamped. But for now, hopefully this is enough to give you a rough idea of what we're going to be doing, and then we're going to jump into the code in the next video. So the first video, we're just going to set up our main Go file, and we're going to set up our flags, and we're just going to add a little comment that sort of outlines the steps that we're planning to take. So this is going to be a really simple video, I think. And then the next video is where we're going to start looking at how to get web pages with Go code and things like that. So to start, we're going to atom main.go. We're just going to do this in a main package because this is meant to be something that we run. It's not meant to be a package that's going to be used by other code. So that's roughly what we're going to want. So I'll start off with this main package, and I'll just save it to get rid of that format I'm not using. So the first thing we're going to do is just get the flags that we need. So I know long term we're going to do a depth flag, but for now we're just going to start with a URL flag. And I'm calling this URL flag instead of just URL. The reason I'm doing that is not because I always name my flags something flag. It's actually just because I'm going to be using the URL package, and I don't want that naming conflict. So I don't name variables URL whenever I have a package named URL so that I can access the two and the code can actually distinguish, like, are you trying to access the package or the variable? So this is going to be a flag named URL. Its default value is going to be, what do Gophercises.com? There's no www for Gophercises, I don't think. And then the usage is going to be something like the URL that you want to build, if I could not do typos, that you want to build a sitemap for. All right, so once we've got our flag, we're going to do flag.parse, and we're going to save this. So this should go ahead and import the flag package. It's complaining because I'm not using the URL flag variable yet. So what we'll do is we'll just print it out for the time being. And that should work. Go run main.go, and we just get gophercises.com, the default value. Okay, so the next thing is we just want to sort of think about what our steps are going to be. And one of the better ways, in my opinion, to do this is just sort of put a comment in your code of what you plan to do. So what I'm planning to do is, first, we are going to get the web page. And I put this in capital GET because we're going to be using the HTTP verb get as well. So I just tend to do that when I'm saying that. You don't have to, it's fine. But we're going to go get the web page, get the HTML from it. We're going to send a get request to get that page. The second thing is we're going to look at how to parse all the links on the page. And really that's not a complicated step. It's just using the package we wrote before. The third step is we're going to build proper URLs with our links. So by this, I mean, we might have links that are just going to a path, and then we'll actually specify the URL. And we might have links to mail to, things like that. We're going to go through all those, and we're going to sort of figure out which ones we need to change. So the ones that are just paths, we're going to go ahead and say, all right, let's add the domain to this so that all of our it's easier later in our code to filter out the ones that we want to filter out. And it's also easier to get the pages, because if you call a get request with just the path, our HTTP package isn't going to have any knowledge of what page you're currently on. So it needs the domain added to those links, so those URLs, so it knows which ones to go get. And I do want to take a moment to mention that the reason I don't put this URL like sort of work inside of the link package that we created before is because the link package is sort of meant to parse HTML files and be agnostic of where it came from. Maybe it came from a file, maybe it came from a website, so it doesn't do any work with taking links and sort of normalizing them, but we're going to do that work in this program because we really need to do it, and we're going to know what page those links came from so we can normalize them a bit. All right, so next step, we want to filter out any links that have a different main. So if we have links to GitHub, some other website, things like that, we're going to filter those out. We only want links that are going to be on the same page for our sitemap. And then 5 is going to be, we're going to want to find all of the pages. I'm going to put BFS in parentheses here. So this is going to be the algorithm that I sort of described with the tree, where we're going to start at the top page, we're going to get all of its links. And we're going to go to the next set of links that we have, and we're going to look at all of them. We're going to build a whole new list of all the new links from those pages. So that's going to be how we find all the different pages for our sitemap. And as we find each page, we're going to be doing steps 1 through 4 on each page for the most part. So, that's how this is sort of going to be a cycle. And then our 6th step, we're going to want to print out XML. So I saved this for the end. If you get all the links and you're doing all that, in my opinion, the XML portion of this code is, it's easier than a lot of everything else. So if you wanted just to skip to that video, you're welcome to, if you just want to learn how XML works or something. That's, it's just going to be another encoding package that we're going to use to print out some XML using all the data that we've gotten from steps 1 through 5. All right, so that's roughly what we're looking to do. In the next video, we're going to look at how to get a web page, so how to send a GET request out and get the HTML from it, but this is all we have for this video. In this video, we're going to look at how to get a web page, and to do this, we're going to be using the net HTTP package. So I want to go ahead and just jump over to this. The net HTTP package is the same package you're going to use to set up a web server that takes incoming requests. You also use this to send outgoing requests. They're both related to the same thing, so it makes sense they're kind of all bundled in the same package. So there's a lot of examples in the overview that'll sort of give you an idea of how to do this. There are different things like clients and stuff like that you can use to set up more complicated scenarios. But in our case, we don't have any complicated things we want to set up. We're really just saying, here's a URL, go make an HTTP GET request to it. So to do that, you can use the GET function, which is provided by the HTTP package. It's just right here, response comma error equals http.get. And then you pass in the URL as a string. This will return the response and an error if there is one. But one thing that's important to note before we move on is this line right here. The client must close the response body when finished with it. So this is important because if you don't do it, you're going to have a memory leak. And for a small application, it might not matter, but if you have something that's running as a web server, something like that, these memory leaks will slowly build up and eventually your server will crash for some reason. And that reason is because it ran out of memory. So to do this, you call this right here line, response.body.close. It's just a method that's on the body that you just call to say, hey, I'm done with this. The garbage collector can deal with it. To do this, the most common way and the way I'd suggest is to use a defer statement. Now, there are definitely situations where it might not work, especially if you need to make a GET request and for some reason return the response or give the response somewhere else so it can deal with it. And in those cases, you need to make sure it does get closed. But the easiest way is if you make the GET request and you handle it all in the same function is to defer that close to the end of that function call. So I'm going to go ahead and I'm just going to copy all of this actually. Paste it in here, and then I'm going to replace URL flag with this part. So I'm going to put a panic here just for the time being. And what is going on here is defer is kind of like, you've probably seen the go keyword where you call some, maybe you call main or some other function. Main's a bad example there, but Go will run this in a Go routine. When you tell it, here's the function that I want you to call in the Go routine, and it'll do that. Defer is something sort of similar, except instead of running it in a Go routine, what it does is it says, run this function whenever the current function I'm in exits. So whenever this main function exits, it runs this response.body.close. Now, there's two real benefits to having this defer over just, because realistically we could just write this code, response.body.close at the very end of our main function, and then we don't really need this defer. That's what you might be thinking. The two benefits to having defer is, first off, you can put this response.body.close really close to your code that actually opens up that body. So here when we're making the GET request, we can put the close almost immediately afterwards. So it's very clear that these two things are linked and that we do handle closing it. And you can look here really quickly and be like, is there a memory leak? Is there some sort of leak with this response body? Well, I can see 4 lines down that we close it, so I don't think there's a leak. On the other hand, if you have the response body down here, it's easy to sort of forget about it. Somebody later might delete that code and not realize it. So there's all sorts of complications. The other issue with calling this, sort of at the end of your code is that you might have something like if some condition return. So maybe you have some case where, if something goes wrong, something else happens, it returns. Well, the downside to not having that body close, in a defer is that now it's not going to get called. Your code's going to return right here at line 21. It will never get to line 31. But if you were to instead do defer response.body.close, wow, I can't type today. Now it doesn't matter where your code returns or anything like that. You don't have to think about, all right, did I close everything that needed closed? Instead, it's going to get taken care of. That's all here. So, just another reason to use those defers when you're opening up things like response bodies. And I'm going to go ahead and copy this, move it. Just move it up here for now. All right, so the last thing I want to do before we're done with this, because that's really all we needed was to learn how to make a GET request with the HTTP package, but I want you to see the response that we're getting. So in order to do that, what I'm going to do is I'm going to use the IO package. It has a copy function, which will allow you to copy from a reader to a writer. So our writer is going to be os.standardout, which is just your terminal. And then the input, the reader, is going to be the response.body. And I think this returns something. Yeah, it returns the number of bytes written or an error. I'm not going to bother with either right now because it just doesn't, there's no real reason to check it in this program because we're just going to run it and then eventually delete that code. All right, so you can see here, we get this whole spiel of HTML, and that's all the HTML that got retrieved from our web request. So seeing that is actually good because it means that moving forward, we can actually take that HTML, pass it to the link package we created, and start parsing out links. And we're going to do that in the next video. Now that we can get web pages, the next thing we want to do is parse the links on the page. So this is going to involve using the link package from before, and then we're going to have to do a little bit of modification to the links that we get back so that they're actual links that we can go get, send GET requests to. Because if they're just links that are like to a path, or say they're a mail to link, for like an email address, those aren't going to work. So first, let's just go ahead and delete this. What we're going to do is just go ahead and say links, comma, underscore, colon equals link.parse, and we're going to pass in the response.body. So link.parse is a function provided by our link package. So once I save this, it will import that Gophercises link package up here. And the links here are going to be the response. This second thing is the error that you get if you're parsing a response. I'm just going to ignore this for now. Later in our code, we're also going to ignore it, mostly because if a page ever has, if we have an error trying to get the links, what'll more than likely happen is we'll get an empty link slice back. So knowing that our code does that, even if it doesn't do that, that's fine. Basically, the gist is if there's an error there, we're just going to go ahead and just not include any links from that page for the time being. Now, you might want to alter your code a little bit. Maybe when there's an error, you want to say, hey, there was an issue. But there could also be the case that maybe the error comes from like malformed HTML or something like that. I'm not really sure exactly how our link package works for that sort of thing because I haven't tested it. But, that's the kind of thing that maybe you want to test. But for now, I'm just going to go ahead and assume that if I don't get links back, well, we're just not going to use them. So here we're going to say for underscore, which would be the index. We're going to go ahead and ignore that. L colon equals range of links. And let's just print this out. And I'm using L instead of the word link here, again, because link is a package that we're using and I don't want to sort of cause naming conflicts or something like that. So I just went ahead and just used L instead of link. All right, so that should allow us to run this, and you'll see here that I have a ton of links. There's all sorts of links. Some of these are fragments, so they start with the pound, and that means they're a fragment that stays on the same page, but the link will just sort of send you to a different section on that page. Others are links to a full URL, like this one. And then we also have things like mail to, and I'm not sure if my page, oh, it has /exercises. Okay, it does have a path specific link. So there are different links depending on what you're looking at. So we're gonna go ahead and look at how to handle these. So the 4 use cases that I think we need to touch are, let me go ahead and just put them here. I think we have path, so something like some path. We're also gonna have something like, let's just do Gophercises, not Calhoun.io. Gophercises.com/some path. Another thing you might get is fragment, or you might have the fragment mixed with some of this. So you might have some path, with the fragment there, or something like this. So both of those are options that might be there, but I don't consider them a separate use case because they're not something I need to consider right now. And then there's also things like mail to John@Calhoun.io. So all of these are possible, hrefs you could get inside of a link. And realistically, we don't want to handle all of them. What we really do want to handle are ones where it's a full path like this. So it has the HTTP prefix, it has a scheme of some sort, either HTTP or HTTPS. It has the full path, or the full link there. And we only want ones of these that go to the same domain we started on. So, if we're on Gophercises.com, we want to stick to that domain. And just the same, when we have these paths, we want to use those as well, but we need to add this Gophercises.com domain because, we can't just call http.get/somepath. Like it's going to be like if we passed in some path here, it's going to be like, I don't know what that is. I don't know how to go get that. You didn't give me a domain. So we don't want to, we don't want to have that. We want to go ahead and fix that. So we're going to do this with, I think, three simple rules. The first is that if the URL starts with a /, so something like this, if it just starts with a /, we're going to go ahead and assume that it's the same domain, and we're going to go ahead and add the domain that we have. Basically, we're going to get the domain from this response, and we're going to use that domain. The second thing is if it starts with HTTP or HTTPS, which they both start with HTTP, so we can just go ahead and use that prefix. We're going to go ahead and assume that it's something like one of these links. Now, it might not be. Maybe they somehow have a really weird schema. I don't know how that would work, but who knows. So there might be cases where there are issues. You don't want to include it necessarily, but we'll be able to filter those out later. And I should also mention that I don't know if there's some other paths, like maybe, I know with like CSS and that sort of thing, you can do something like this, which sort of implies some.css, which I believe is sort of a way of saying, all right, I don't care which protocol you use, whether it's HTTP or HTTPS, I want you to use the same one that the current site has. And I don't know if that works for href paths or not. I've never really messed around with it. So it's possible there could be an error whenever if that was the case, but I'm just not going to worry about that right now. And if you do run into it in your code and you want to handle it, you can go ahead and tweak the code, and just basically all you'd say is if it has the prefix // well, that's not what you wanted. You only want pages that have maybe this prefix. Or maybe you want to handle it a slightly different way. It's kind of up to you, but we're going to go ahead and ignore that for now because I don't want to go down this rabbit hole of trying to get every single scenario. So first rule, if it starts with a /, we're going to add the domain to it, and then we're going to use it. Second is if it just has the domain that we want to start with at the start, we're going to go ahead and use it. So if it starts with HTTP and it's the same domain, we can use it. The third rule is if it starts with anything else. So if it starts with a fragment, if it starts with a mail to, we're just going to skip it. We're going to not include it in our list of links. I know that might sound a little harsh, but I think that's just going to be the easiest way to go about doing this for the time being. And I should also say that when I talk about this domain one, filtering out the ones with the correct domain is something we're going to do in a future step. So really what we're doing right now in our rules is if it starts with a /, we're assuming it's a path and we're adding our own domain and adding it to our list. Second rule is if it starts with HTTP or HTTPS, we're going to go ahead and assume it's a full URL like this, and we're going to add it. Third rule is just ignore it otherwise. So that's it. So to do this, we need to first get a base domain that we can add when we have paths like this. There are different ways to do it. You could try to parse it out of the URL that's provided up here as a flag, different stuff like that. What I like to do is I like to look at the domain from the request that we just made. So this response is going to have a URL inside of it. That's the final URL that it ended up going to. And the reason I like this is, say somebody gave us the URL gophercises.com and it redirects to www.gophercises.com. Well, we probably want to use the www in that case, because if the website's redirecting you, chances are any absolute path links are going to include that www subdomain. And whenever you're generating any links like this with some path, realistically, if you were to click them inside of a browser, they would now include that subdomain. So you want to include the actual URL that was used, not the one that you initially made your GET request with. So to do this, we're going to say the request URL is going to be equal to the response.request, which is an http.request pointer, and this has a URL inside of it. This is going to be the final URL after any redirects or anything like that. So what I'm going to do before we move on is I'm just going to show you that if I change this to HTTP, so it doesn't have the HTTPS, and I run this code, and then I do print line with the request URL.string, and I'm just going to go ahead and comment out this so we don't print out all that. Let's comment the whole thing out. Actually, if I do that, it's still going to complain. So I'm just going to leave it there. It's fine. So if we run this, you'll see at the very end, we have this URL. So you'll notice that this one has HTTPS, even though that's not what we have up here. So what's going on is that my website, the Gophercises site, will redirect you to HTTPS when you're not using it. And that's intentional because I want to make sure you're using a secure connection and all that stuff. But that means that, by doing it this way, we know that we're going to get that redirect. We're going to get the URL from the redirect, and that's what we're going to be using here. So once you have that, we want to build what I'm going to call a base URL. And this is going to be, the reason I'm breaking this off and not using the request URL is I only want 2 pieces of information from the request URL, and rather than trying to zero out the rest, I find that it's easier just to create a new one, and I know the rest of it's going to be zeroed out because it's a new object. So we're going to say we're going to create a URL.url. And the 2 pieces we care about are the scheme, which is things like HTTP, HTTPS. It could be other things, I think like FTP and some other stuff like that are all valid in there, but you're not likely to see them very often. So we've got request URL.scheme, so we want the same scheme it had. And then we're going to have the host, which is going to get the request URL.host. So we'll save that. And then we're going to say base is equal to the base URL string. So we want to go ahead and just convert this into a string, and then we'll print out the base. So this should, give us gophercises.com down here, same as before. But you'll see later, let's say if we do, so if we go to /x, actually it's, I think it's, there's one up here. There's a demo right here. I think. This one right here is the one I want. So if we use this Choose Your Own Adventure demo as our link that we're starting with, you'll see that we only end up getting this, even though I want to go ahead and print these. Request URL, and then we'll say base URL. All right, so you see here the request URL was something a little bit bigger. It had the demo's path, or /demo/CYOA, and the base URL we pull from it does not have that information. It just has this portion here, which is, just the domain that we want to be working from. All right, so now that we pulled a base URL out of this and, turned it into a string that we can work with, the next step is going to be, sorry, I was looking at something real quick. The next step is going to be, we want to go ahead and build those roles I mentioned. So we're going to do something like, var hrefs. It's going to be a string slice, and we're going to say for _L in the range of links. And we're going to do a switch statement in here because we have a couple, we have those 3 different situations. So first it's going to be case strings.hasPrefix. So l.href is the thing we're checking, and then we want to see if it has the prefix slash. So if it does, we're going to append to hrefs. We're going to go ahead and append this base URL we just created plus slash plus, actually we don't need the slash because we know that our href starts with a slash. All right, so plus the href. So this right here is how we're building the string, which is not necessarily, maybe it's not the most ideal way to build a string or build the URL. But for now, I think it works fine. We know what the base URL is roughly going to look like, this base that we created. So this should be fine for the time being. At least I don't anticipate any issues. The next thing is if strings.has prefix, and we're looking for HTTP. So this will include HTTP and HTTPS because HTTP is a prefix to HTTPS. And in this case, we're just going to append hrefs with this current href. So the current link that we have, we don't need to do any modifications to it. We can just go ahead and append it. Otherwise, if neither of those cases are true, we don't do anything. So you could do something like default, and maybe you'd print something out like, oh, we're skipping this, whatever you want to do, just so you can sort of log it and see. But we're just going to go ahead and leave it blank for now. And then I'm actually going to come up here and I'm going to copy this code and delete it. And I'm going to put it right here, except I'm getting rid of the for loop. All right, so we set up the request URL and then we build the base URL. We parse the links and then we go ahead and build our href string. So now we can do print line, no. All right, and if we run this, we need to change that though, that's for sure. All right, so we're going from the Gophercises page, and you'll see here that we're getting a whole bunch of links now. And all of these have domains now, whereas before, when we were up here looking at it, you'll see that we had some things like sign up, we had some things with just a slash exercises. Now all of our hrefs are, in the href slice that is, are all full URLs that we could go ahead and make requests with. Okay, I believe, yep, that's everything we need for this. So what we're going to do next, we're not going to do it in this video, but what we're going to do next is we're going to look at how to first split this code into functions. And then in the following video, we're going to go ahead and we're going to look at how to filter this sort of thing. So how we can go through and filter these links to just be the ones that we actually care about. So we've got all this code written. The next thing we're going to do is split it into a function, or a couple functions actually. And at least I think, let me look at this. Yeah, definitely makes sense to make two functions, I think. So basically we're going to split it into some functions, at least two, I think. And the reason we're doing that is we know that this is the type of work we want to do for every single page that we build a sitemap for. So like right now we're just, we're doing an HTTP GET, we're getting the base URL, we're parsing the response body, doing things like that. But realistically, we want to do this type of work for every single page that we get a link to, that's on the same domain. We want to go ahead and do that same work. So what we're going to do is split this into, I think we'll start with two sections. So the first is going to be, we'll call it function hrefs, and it's going to take in a reader, which is probably going to be, it's going to be the response body. I know that for sure. And it needs this base string here, so this base thing. So if we look at this big chunk of code here, you can see the only real things it needs is this io.reader to parse, and then this base here, which is what it uses to sort of build URLs when it's just a path URL. So with just those two pieces, it can return a slice of strings that are all of the hrefs. So that means we can copy all of this code, paste it all here, and we can say, let's say pages : equals hrefs response.body, and then the base is the base that we built there, and we can do this for loop that we have here. We'll copy it and bring it back up, and all we have to do is for page and pages, print out that page. All right, so this should be roughly the same, but we need to fix a couple of these things inside of this function. This link.parse, for example, we need to give it, why did I name this body? We'll just name this R for reader. There's no real reason to change it to anything else. We could name it HTML or something like that if you wanted to be more explicit, as to what type of reader it's going to be, but I think R is fine. So this is going to take in the reader. It does all this. The base is still the same name, so that's fine. And then at the very end, we're going to return those hrefs. And I probably don't want to name that hrefs. We'll name it ret. The reason I'm naming it ret instead of hrefs is for whatever weird reason. Maybe we wanted to make this recursive or whatever. I don't tend to name my variables the same as the function that they're in. It just seems a little bit weird. It's not that you can't. I mean, that code seemed to have worked, but I just don't tend to do it. All right, so we've got this function, and let's go ahead and make sure this is still up. Sorry, that's not what we wanted. All right, this still appears to be working. That's good to know. I think that's all exactly the same. I guess there's one new Twitter link because I just did a release that, long story. I did a release that had a link to my own Twitter account because prior to doing that, random automated bot type tools would pull Marcus Olson's and say that the whole thing was by him, and I didn't want him to keep getting mentions and have to correct them every time. All right, so going back to this, the next function we're going to do is this whole getting the web page thing. So this whole part here where we get the page, we do something if there's an error, we defer closing the body, and then this part here where we build the base, and then we get the hrefs. So I'm going to take all of this, and I'm actually going to make it func. Let's call it get. It's going to take in a URL, which is a string, and I don't like calling this URL. Let's call this, we can just call it URL str, that's fine. And it's going to return a slice of strings. So this is going to return all the links from a specific page. Eventually it's going to also deal with the filtering work, but for now it's just going to do the same thing we had. So I pasted everything that I'd copied from up there. I'm going to go ahead and save it. And then up here, what I'm going to do is I'm actually going to pull a little bit of this. This pages part, I'm going to pull up here. So I'm going to say pages, equals get URL flag, and then keep all that. So I don't need this part here. And then this is going to take URL string. It's going to use that. And then at the bottom, we need to return hrefs, response.body, and base. So really all we're doing here is just a little bit of refactoring, moving code around into functions, making it a little bit easier to reuse it. We're not really adding anything new at this point. I think that's good. So if we run this, it should be exactly the same as it was, and it looks like it is. Okay, so we've done those two things. We split them into functions. Now it should be a little bit easier every time we get a different URL to go ahead and call this get function, and it'll handle doing all that work for us. So what we're going to look at next is how to filter out any of these URLs that aren't where we want them to be. So if they're a different domain, if they go to Twitter, anything like that, we're going to filter that out. So to do this, we're going to do it, let's do it two ways. Let's first just see how to just hard code sort of a filter, and then I'm going to show you how to do it in a little bit more, get a little bit more flexibility is what I'll say. So the first is filter. We take in a base, which is like the prefix that we're expecting to have. This is the domain that we're currently on. And then we're going to take in a slice of links, which will be slice of links, which is, string slice. And we're going to return a string slice. And what we're going to do is we're going to say var ret. And then at the bottom, we're going to return ret. So I'm creating a new slice. I probably wouldn't have to if I didn't want to. I could probably modify links and then just return that or something. But in this case, I'm going to go ahead and create a new one because the way I'm expecting to use filter is just calling filter and assigning whatever it returns to the variable. And sometimes creating the new slice makes it a little bit simpler to, just a little bit simpler to write the code. Even though there's a little bit more memory usage at first, I don't think that's a big deal right now, especially with, how small this program is. It's just not that big of a deal in my opinion. So we're going to say for underscore comma link in the range of links. And here we're going to do some sort of filtering. Well, right now the filtering is going to be really simple. If strings.has prefix, and then we're going to say the link has the prefix of base, which is sort of the base domain we're working with. So this means that if our base is https://gophercises.com, and if our link is the same thing with maybe some path, it'll keep it. Even if it doesn't have the some path part, it'll keep it. But if it happens to be something like github.com or whatever else, it's not going to keep those. So we say ret equals append, ret, and link. And that's it for this filter. So basically all we're saying is anytime it matches this criteria, add it to this ret slice that we're going to return, and then return that slice. So then we can come up here to our get, and we can do filter, and we want to pass in base as the first argument, and the links is the second argument, which we can just go ahead and pass in whatever we get back from hrefs. So now if we run this, you'll see that our links got really limited. We've only got these 4 links. Technically these 2 are pretty much the same thing, but we're going to go ahead and just keep them separate because it's simpler for now. And there will be more pages eventually. Once we go get all the links from these pages, we'll see that there's some more links on the page. But from the home page, these are the only 4 links, and one of them is really just the home page. So, we see that it's working, but this filter function is, it's pretty brittle. We can't really add any specifics. We can't, optionally filter based on certain things. Maybe we'll have 2 different sitemaps, we'll have options or something, and we want to change them. So what I'm going to suggest is instead of putting this base hard-coded in there, what we're going to do is add a keep function, which is going to be a function which takes in a string and returns a boolean. So the idea here is that what we're going to do is replace the strings.has prefix with keep function. We'll pass in the link, and if this returns true, then we're going to keep this link. Otherwise, we're not. So what that means for the rest of our code is that we need to provide it with some sort of function, some sort of keeping type function. Well, let's go ahead and add with prefix. We'll do prefix, which is a string, and it's going to return a function that matches this same definition. So it's going to return a function that accepts a string and returns a boolean. So we're going to return func link string bool. So this right here is a function that the thing we're returning that accepts a string, returns a boolean, and we're going to name it this time because we want to actually be able to work with a variable. And what we're going to do is we're going to say return strings.has prefix if the link has the pfx prefix. So if this is true, we keep it. If it's not true, we don't keep it. So this ends up being the exact same thing we did before. We've just broken this into a closure that we can now use as an option for this filter. And you might even want to, maybe you'd want multiple keep functions for some reason. And if any of them were true, you'd keep them. Or maybe it's something different. How you want to write this specifically is up to you. But we can now come up here, though, and change this code to be with prefix base. And now this is a little bit clear as to what it's doing. It's saying, all right, filter all of these links that come back from the hrefs call and keep the ones with prefix. So, it's not that it's not even necessarily the clarity that is the reason that I'm doing this. It's one of the biggest reasons is just it makes this filter function a little bit more useful down the road if we decide to change things up. Okay, I think that's everything we need to do right here. Let's go ahead and run this and make sure it's the same. All right, we're getting the same exact results back. They're all the same domain. Now that we have all these different functions, we have a way to get any single page and get back a list of all the links from that page. What we're going to do is look at the BFS portion. And this is all going to be in the next video, but we're going to look at the BFS portion to do that whole searching or going to all the different pages and looking at all the different links and building this sitemap up. Exactly like I described in the strategy type section of the strategy video where I went over the overall strategy for how we're going to approach this problem. We're going to start working on that in the next video. We're going to start looking at how to implement the BFS, as I mentioned at the end of the last video. And I am going to just go ahead and suggest that at this point, I know it's a bonus thing, but I would probably recommend at this point, if you're trying to code this stuff on your own, to go ahead and add the depth at this point. So we're going to add it right here. We're going to say depth colon equal, actually let's call this max depth colon equals flag.int. We'll call it depth here as the argument, because I kind of like to keep the flag names a little bit shorter. We'll make the max 3. The deepest we'll go is 3 for the time being. And we'll name this something like the maximum depth or number of links deep to traverse. I don't know, it's hard to sort of describe that one there. But basically the idea here is if you don't have the depth and you have a cycle of some sort or a loop of some sort, your code is going to continuously, just keep on going back and forth, or you keep going through that cycle. By adding the depth, you can at least see if most of your code's working, even if there is some sort of cycle. And then later you can come back and get rid of that, or just add a depth that's so high that like you should never actually be hitting it. So for example, with the Gophercises site, I think it's a depth of maybe 10 would be plenty, that you don't actually need anything more than that. But maybe if you set it to 100, if you see your code's actually going 100 layers deep and actually still getting new links, then that means that you have some sort of issue. So this is going to complain because we aren't using max depth. We'll use it here in a second. We're going to go ahead and add this func BFS, and it's going to take in, let's just take a, I don't know, I was going to call it base, but it's not really a base. We'll just call it a URL string, and it's going to take in a max depth, which is an int. And it's going to return a slice of strings. And this slice is not going to be for a single URL. This is going to be all of the URLs that should be used in the sitemap. All right, so inside of here, we're going to go ahead and start implementing this. And the first thing we're going to do is we're going to go ahead and create a map called scene. And this is going to be a map of all of the URLs we've ever visited. Now, the reason we're going to keep track of this is we want to go ahead and, if we ever go see, say, gophercises.com/CYOA or demo or something like that, once we go get that page and get all the links from it, there's no real reason to get it again. There really isn't a good reason to go get the same page multiple times, because the data isn't going to change in a couple seconds, or it's very unlikely to. So what we're going to do here is create a map, and we're using a map because this key will allow us to sort of keep track of, it's sort of like a set. If we put this in a slice, we'd have to go through the entire slice to see if the string that we're looking for is in it. But with a map, this key is going to be hashed, and we can quickly look up to see if there's a value inside of the map for that key. That means we've already seen that page and we don't need to look at it anymore. So it's kind of a way of keeping a unique set of all the pages we've seen without actually having to create a data structure for it. And the second part, the struct, this is something you'll see. You could make this like a bool, something like that, and like every time you see a page, set this boolean to true, and that would work. I'm going to use the struct because the struct actually uses a little bit less memory, and it's something you'll see people in Go doing a lot. If you use, I'll link on the video at this point. Actually, let me go see if I can. Yeah, I have it in my notes. Right here. I'll link it in the video as well whenever I edit it. But basically, Dave Cheney has an article where he talks about this. Basically, the empty struct is something that it doesn't allocate anything in memory. It shouldn't, it should just be an empty thing in memory. It shouldn't be wasting space or anything like that. So really, all this map ends up having in memory, or the keys, not really any values associated with them. So it ends up really being like a unique set of items and not like a map wasting memory. Whereas if you put a bool here, there'd still have to be some memory to sort of store whether this is true or false. So I know that sounds a little bit weird, but it's just something you'll see in some Go programs. So it's probably nice to get used to it now so that whenever it pops up, you're not confused. All right, the next thing is we need a queue. I'm going to make this a map. Again, it's going to be string and structs. Your string is a key and struct is the type. I want struct here. This is going to be, we're going to have a queue and we're going to have a next queue. So NQ is what I'm going to say for next queue. And next queue is going to actually have a value inside of it. And you'll see why here in a second. And this is going to have the value of URL string. And it's going to point to, or it's going to have the value of an empty struct. All right, so we have queue and next queue. Queue is the one that we're currently looking at. So this is the list of all the domains that we need to go do it, call this get method with. So that's what it's going to store. Every key in it is going to be a URL that we need to do a get with. Next queue, NQ in our code, is going to be the queue that we're going to take all the links we get from those pages that we have not seen yet. We're going to add them to NQ. And whenever we've gone through all of the links in queue, we're going to go ahead and then take NQ and assign it to queue and then repeat our loop. So basically, let me see if when we're looking, say we're looking at this layer here, this would be our queue, whereas this green part down below it, this would be our NQ that we're slowly filling up. As we go to this page, we'd add these 3 to NQ. As we go to the Let's Learn Algorithms and get all the links from it, we'd add these 2 to NQ. And we're just slowly filling them up. And then once we've gone through everything in our first queue, we then look at the next queue and we start filling up a new next queue. So what this ends up looking like in code is for I is equal to 0, I is less than max depth, I plus, and then we're going to say queue NQ equals NQ make map string struct. So this is going to look really weird. So right here, I'm assigning 2 different variables. So Q is going to become whatever's in NQ. So I'm going ahead and moving NQ over to Q. So that's like if you're looking here, once we're done with this whole section, then this Q that we were building becomes Q. And we'd have a new Q down here below that we're going to start filling up. That would be our new next Q. So that new Q that's going to be empty when we just started is this second part, the make, where we're going to go ahead and say make a new Q for us to use. And then what we're going to do is for URL, and then I think URL is fine. For URL, this is actually wrong. Yeah, I don't want that. I want for underscore URL in the range of Q. Oh, sorry, it's not a slice. That's why. Okay. So normally if you're iterating over slice, you do something like you have for index, comma value in the range of the slice. So since we're doing maps here, maps are a little bit different. You have for key value in the range of a slice, or a range of some map. So it's a little bit different in that sense. And then another thing to keep in mind anytime you're writing code like this, iterating over slice, you're guaranteed to sort of iterate over the slice in the same order. So slices are kind of like arrays in the sense that they are in the same order every single time. When you iterate over them, you'll go from the 0th index all the way up to the max index. A map in Go is a little bit different, and the way you iterate over the keys is not guaranteed to be the same every time. This can be confusing and slightly annoying in some situations, so just keep it in mind. In our case, it doesn't matter. We don't care that much. So we're going to say for URL, we'll do underscore for the value. We don't need anything. And then the map is going to be this queue that we have. So we're going to say for all of the URL keys inside of our map, what we're going to say is if underscore OK is seen with that URL, and if it's OK. So what this is doing is seen is a map. So when you want to access something in a map, you do something like seen URL. Usually when you do this, you'll get the value back. So it'll be value : equals seen URL. So this value here is whatever was stored inside of this map. Well, we don't actually care about the value that's inside of it. In this case, what we actually want is we want to know if there was a value there. Well, with maps, you can add a second argument on the left-hand side. And this second argument, it's really often called OK. This argument is saying whether or not there was actually a value with that, if that key existed inside of that map. This will be true. Otherwise, it'll be false. So in this case, we're saying if, tell me if there was a value with this key inside the scene map. And if there was, this OK will be true, and this if block will be evaluated. So if that's the case, we're continuing. So the reason we're continuing is we're saying that if we get a link to a page, if our queue has a page or a URL inside of it that we need to go look at, but we've already seen it. So seen here is storing pages we've actually called a get on. So if there's a page that we've already seen, there's no point in doing it again. We don't want to go hit that again. And I will mention that there are different ways to sort of write a BFS and you could write it so that, you really limit the number of times you put already seen URLs in your queue. I'm not going to be doing that here, mostly because it's a fairly minor optimization for our code right now, especially considering that we're actually making web requests, which are way slower than iterating over, things really quickly in memory. So knowing that, I think it's fine just to leave them there, and it really makes the code much, much simpler. So for this video, it's much easier to sort of show you the simpler version, and then you can go in and try to optimize it if you want to. But, getting into those details just doesn't make sense right now for the time being. It's just not worth the slight improvement in speed we'll get. Okay, so we're saying here that if the URL has been seen, we're going to skip it. Otherwise, we're going to go ahead and say, mark this URL as seen. So I know that's all right away. No, sorry, it seems weird to first check to see if it's seen, and then if it isn't, just to go ahead and immediately mark it as seen. But if we get past this continue, which we'll go ahead and iterate over the next key value pair in the queue, if we get past that, at this point we know, all right, well then we are going to go see it right now, so we might as well just mark it right now. All right, so we've seen this URL. We're going to mark it that way, or we're going to see it, so we're marking it. And then we're going to say for link in the range, and then we're going to go ahead and get the URL. And we're going to pass in the base. And I think that's all we need to do there. Yeah, okay, that's all we need for code there. So basically what we're going to say is for every link inside of the slice of links that we get back from getting that URL with, actually base should be URL string. And then actually, yeah, that's URL. I probably should have named this URL because the URL package making it a little bit confusing, but it's fine for now. And we actually don't need that. I don't know why I'm thinking there's a second argument there. Oh, in one of the versions I prototyped of this, there was a second argument there. That's why. Okay, so basically, let me go ahead and just start over here. We want to get this URL, so we're going to say links : equals get URL. So that's what we could be doing. And then we could range over this links, but rather than just creating this variable, what we can do is just go ahead and just put this part here in line because we aren't going to use that link slice for anything else. Didn't mean to try to remove that, so that's good that it didn't remove it. All right, so basically what we're going to do here is we're calling this get URL. We're ranging over all the links we get back, and then for each link, we're going to put them in the next queue. I need 2 of these. Okay. So I know that these are looking weird too. Before I move on, I should probably stop. Whenever this first part, the struct with the 2 squiggly braces, that's defining the type. So I could actually define this up here. Type empty is going to be struct like this. So if I did that, I could actually come down here to these and replace a lot of these with empty. And then down here, I could say this is empty. And then for these, I could just say we're going to assign it to empty. And then the second sets you're seeing are when we're instantiating it. So we're creating an actual instance of that type. So we could use this empty type, and that would probably make it, or possibly make it a little bit clearer. So if you want to do something like that, you can. I'm actually going to undo all of that and just keep it like this. But that's why you're seeing these 2 sets of squiggly braces, which can be a little confusing at first. This first part is sort of defining the type. The second part is instantiating it. All right, so I think that's everything for our BFS. We're gonna have to return something here at the end, which is going to be, it's all the URLs we have seen. We're just gonna return that for the time being. I take that back. We need to turn that into a slice. So we're gonna say for URL underscore in the range of seen. And then what we're going to do here is var ret, it's going to be a string slice. And we'll say ret equals append ret with the URL. If you wanted to slightly optimize this, one of the things you could do is do ret : equals make string slice 0 length, because we want to use append still. We'll do 0 length, but we could set the capacity to whatever the length of scene is. So this will go ahead and pre-allocate all the memory for our slice. And then when we call append here, it'll go ahead and it'll still use the same memory we have, and it won't have to do any more allocations. So it's minor optimization, but it's pretty easy to do, so we might as well do it here. So I think that's everything. Just a quick review, because I know this is the most complicated part of this exercise, I think. We're setting up, this right here is all the things we've seen, all the URLs we've seen as we go through this. Q is going to be, Q and next Q are our Qs of, things to look at. We put URL string in next Q. And the reason we do this up front is because as soon as we get inside this for loop, we go ahead and assign Q to whatever's in next Q. So if we set this inside of it, we'll know that the first time we look at Q, it'll have one URL, and that'll be the base URL that we want to look at. So our 0th range, with 0 clicks, that's how many it'll go. Now, the one thing this does imply, though, is that because our max depth is probably something, it's probably supposed to be, 3 is meant to be click 3 times, not less than 3 times. We probably do want to change this to less than equal to max depth instead of just less than. So I added that equal sign there. So once we do that, inside of here, for every item in our queue, we're going to go ahead and pull out the URL. We're going to check to see if we've seen it for some reason. There's always that chance that we might have seen it, so we might want to go ahead and keep that in mind. Then we're going to go ahead and set it to be seen. We're going to go over all of these URLs and add all the new ones for the next set of queues, or the next queue to look at. And then that whole loop will repeat again, because everything that was in next queue will then get assigned to queue again, and next queue will become a new slice, and we'll do all that work all over again. All right, I want to just quickly test this, see what it looks like. So we'll do URL flag and max depth. We'll do pages, : equals, and then we'll just print all of these out. Oh, it's supposed to be pages, not page. Okay, so if we run this, you'll see that we're getting a lot more pages. So what's happening here is when it goes to the Choose Your Own Adventure page, well, this actually has links to other pages. So this is going to link to the debate, the Denver, New York, the pages like that, and it's eventually going to sort of traverse that way. And if we actually increase this, say to 10, just run this again, you'll see here we actually get a couple more, because there are a few more pages in that Choose Your Own Adventure demo that I have. But that looks like all of them. I think home is the end. Let me go ahead and verify that to make sure my code is working. Yep, that is the end. Okay. I just wanted to make sure we were actually getting to the end of the Choose Your Own Adventure story. So at this point, our BFS is working. There's a couple minor optimizations you could be making, things you could improve on that you might want to do. One instance of that is for every page we go visit, we mark the URL that we try to get the page with, not the actual URL the page hit. So when we come down here to the get, you might actually want to change this at some point. So remember down here, we're looking at the actual URL that comes from the request. So one of the things you might want to do is you might want to change this get to be string, slice of strings. And the reasoning for this is that you might want to go ahead down here at the bottom to return request URL.string, and then the all the filtered out links that we have. The reasoning for this is that if a URL gets redirected to something or gets changed to something, that's probably the URL you want to use in the long term. But maybe not, it's hard to say. Maybe it redirects to another domain and that doesn't make sense to have in your sitemap. So really, it's kind of like a judgment call as to what you think makes the most sense in these situations. And it's also possible you could have 2 pages, maybe a page redirects to a new one and you really just want the new one in your index. So it's kind of hard to say what makes the most sense there. That's kind of up to you to decide. I'm going to leave it as is for the time being, because I think it's fine and it gets the point across as to what's going on. Another thing that might be worth checking is this panic. We have panics inside of some of these functions that I've left there for the time being. In some of these situations, maybe it just makes sense to return an empty string slice. So maybe if we can't get a page for some reason, it makes sense to say, all right, well, we're just going to assume that it doesn't have any URLs to go from. That's something you could do. And I think we actually do something similar down here with the links, where if there is an error parsing links, we just go ahead and assume there's none to work with. So it's not a terrible thing to try there. It really just depends on your situation again. Okay, so that's everything I'm going to cover right now with the BFS. There's one more video, I think, and in the video we're going to look at the XML portion, just how to print this all out as XML rather than just a list of URLs, and that should be a little bit simpler. Again, I know that this BFS section is not the clearest if you aren't familiar with it. And again, I would really love to cover this with a more algorithm-specific talk, but it's going to have to wait for another video, possibly another course, you know, in the future, because right now I have a lot of these videos that I want to get out, and I don't want to spend too much time on something that's not going to teach you Go, but instead just going to teach you algorithms right now. All right, see you in the next video. All right, last video, I hope. Let's go ahead and look at how to print out some XML. To do this, we're going to use the encoding XML package. Let me go ahead and look it up. And this package is going to be there's a bunch of encoding packages in Go. They're all fairly similar in the sense that they follow a lot of similar designs, a lot of similar ways to use them. So if you know one, it's not too terribly hard to jump to another. What we're going to be doing here, I'm going to look for an example. There's an encoder example, and you can see here there's an example. I definitely suggest if you're ever jumping into some of these packages, the first thing I go is the example. You can run them, you can see what they're doing, and they're usually pretty insightful as to how the package is intended to be used. And I probably should have said this in a video way earlier, but that's okay. What we're looking at here is these tags. It looks like this uses struct tags in order to create all these things. And then another thing worth noting is that some of these you can do like name with a greater than sign and then another name. And if you look down here, you'll see that we've got this name field, and inside of it we've got first or last. So this is something that would be nice to use for our use case, but it's actually not going to work, because if you look at this, you'll notice that these two things both have name and then they're inside of it. They both get put inside the same name block. Well, if we were to go ahead and do something similar to that, at least I'm pretty sure if we do it that way in our code, it's going to end up putting all of our locations inside of the same URL tag. So let me go here. We want URL tags, and inside of each URL tag, we want a location tag or an LOC tag. So we don't want a bunch of LOC tags inside the same URL block. So I don't think that's going to work. But it doesn't really stop us. What this does mean is that if we want to go ahead and set these XML tags, all we got to do is create a struct and add some of these things. So let's just go ahead and do that real quick. Let's do type LOC struct. And I'm keeping this lowercase because I'm not exporting it or anything, and there's not really any real purpose to. We'll do value string. It's going to be XML of LOC. We'll do type URL set. It's a struct. And this is going to have URLs, which is a slice of locations. And this is going to be it's going to have XML of, this is the URL portion. So each of these will get a URL tag, and then each individual, I think that's what it's going to do. So each of these, I believe, will have its own URL tag, and then inside each one will be rendered, however it's supposed to be rendered. Each location will be rendered how it's supposed to be rendered. So that should give us something like URL loc for each location object. All right, so let's go ahead and try it and see if it works. Coming down here, we're going to want to do it. Let's go ahead and get rid of this print line stuff. Once we get all these pages, let's go ahead and do our 2XML, and this will be a URL set. I'm naming the variable 2XML because it's what I'm using to get 2XML. Wouldn't have to name it that, but that's fine. And we're going to say for page in the range of pages, 2XML.urls equals append 2XML.urls. And we want to append, I think this is a LOC, and the value is going to be the page. That looks right. Yeah. Okay, so we're doing this because we want to go ahead and just keep appending to the URLs. It might make sense to go ahead and set the length. For example, you might do something like URLs is make LOC, and the length is going to be len of pages. And then here you could do for, keep the index, and you could do something like this equals LOC. I think that'll work as well. I don't see why it wouldn't, but maybe it's complaining. Non-declaration statement, not blah, blah, blah. I don't know. I'm not going to deal with it right now. I don't feel like debugging. It's late and I'm kind of tired. It's probably, I think I know part of the issue. I know there's a comma missing there, but this should be fine. All right, so this should add everything to the toXML structure. Now we want to go ahead and encode it. So to do this, we're going to create an encoder, which is going to be xml.new encoder. And the encoder takes a writer argument, which is where it's going to encode to. Well, we're going to go ahead and write to standard out, which is just your terminal screen. And then once we have that, we might actually, we'll deal with that in a minute. I'm going to say if error : equals encoder.encode to XML, error is not equal to nil. We'll go ahead and just panic with the error for the time being. This is a binary. It should be, we're just running this program, so it should be fine. We'll see it real quickly, and it's at the end of our program. I don't know if we need a new line at the end or not. Let's go ahead and try this. All right, we need a new line at the end. So my terminal is printing out this %. That's not actually a character there. It's just kind of a way of showing you that there's no new line at the end of the output. So you'll see here, if I put that new line at the end, it goes away. The next thing is looking at this. It's really hard to read this. It's really hard to verify if it's correct. So we're going to go ahead and just do something like encoder.indent. And I think we can do empty, nothing for the prefix and 2 spaces for the indent. And let's see what that's like. All right, that looks closer to what I wanted. All right, so we got this URL set. Inside of it, we've got a URL and a location. So coming back to the exercise, you'll see that it's really, really close to what we wanted long term. What we're missing still is this XML namespace attribute. That's what XMLNS stands for. At least I believe it is. And we want to go ahead and set it to something like this. And then the second thing we're missing is this, this version. What kind of XML are we using? Well, I will mention that I noticed this while we were in here. There is a header inside of the XML package that is this version. So rather than sort of trying to create a tag for it or something like that, first thing we're going to do is just xml.header. We'll just go ahead and print it out to the screen. And we can just print it because it looks like it has a new line at the end of it already. So then once we're printing that, then that should give us a little bit closer to what we want. Yep, we got this XML version. So the last thing we need is this, the XML namespace attribute, which to do this, let me see. If you look up ATTR in the XML docs, I was just kind of looking for attribute, but this happened to work perfectly. So when you have a field with the tag, the name, comma, attribute, it looks like it becomes an attribute with the given name in the XML element. So I'm guessing what this means is that we want to do something like XML namespace, string is going to be XML. We want this to be XML namespace, comma, adder. And then maybe we want to add a constant to our code of XML namespace equals, and then let's come here and figure out this is what we want. All right, so we've got the constant and we've got this field for it. So what we're going to do down here is we're going to say XMLNS is going to be XMLNS, the constant that we created up there. And, I know part of the issue here is that I need to do, all right. So I'm going to say toXML is going to be a URL set. We're going to go ahead and set the XML namespace to this constant we have, and then we're going to go ahead and append all those URLs. Once we do all that, we're going to print the header. We're going to go ahead and create the encoder. We're going to do all that work, and it should go ahead and handle that attribute for us. So let's see what happens. And it looks like it's there. Sweet. That's what we were looking for. All right, so now when you're doing this, you could do something like map.xml. So it's outputted to that map. And over here in my code, I can do a map.xml, open it up, and you'll see that we've got this nice map in an XML format, and we can use it to, we could upload it wherever we needed to, do whatever else we need to. I want to go look and make sure there's nothing else, but I believe that's everything. Oh, I do want to mention one quick thing. Going back to our code, there are definitely optimizations you can make in this, but one of the things that you could do is if len of q is equal to 0, break. So what we're doing here is we're saying that if our q, the links that we need to look at is ever an empty string, we want to go ahead and exit here. I believe for that to work correctly, to make sure your code actually does terminate before it hits this max depth, you're going to want to go ahead and make sure that down here, when you're doing next queue, you're going to want to say if, basically what you're going to say is make sure that we haven't seen this URL. So if it's not okay, so basically if it's not in the scene slice, then we're going to add it here. Otherwise, we aren't going to add it. So basically we're saying we only add URLs that we know we have not seen before. But by doing this, we should never add things to our next queue that we have seen. And that means that eventually we should get to the point where our next queue is, it's empty. It shouldn't have anything else that we need to look at, unless a page just has infinite links to it. But by doing that, let me go ahead and just try this and see what happens. This should still work. All right, so mine's still outputting map.xml. But what we could do is just say, well, you could print something out there if you want to. I guess I could just do, let's just do that. It's some big number. I'm doing that intentionally. I is, let's say I equals I. Oh boy, I didn't want to print that out to XML. It's okay though. All right, so it looks like here that it takes about 5 steps down before our current version of the code, eventually runs out of things to look at. So that's what I just wanted to show you that where like if you don't have the max depth, you can write your code in a way that it will eventually terminate, and that's fine. I probably should have done a separate video, but that's okay. But yeah, it's easier with the max depth. I definitely think that it's something that makes sense a lot of the time because you might not want to go ahead and do a sitemap for a page that goes 200, 300 pages deep, or maybe you want to. It's kind of up to you. But it is nice to know that you can go ahead and terminate this if you have already seen all the pages and you don't need to keep cycling through this stuff. Your code should eventually do that, even if you don't have this. I think it'll still eventually do it. I just don't think it'll do it as quickly. And the reason it'll do it, I equals I. Let's go ahead and try this. Yeah, so it gets to 6 and then does it. And the reason it's a little bit less efficient with that is we're still adding all these here to the next queue. But when we get to this point here where we say if we've already seen the URL, don't go ahead and get any links from it, eventually we'll get to a point where our next queue that we end up setting to queue only has pages we've seen. And as we iterate over it in this for loop, we'll basically say like, all right, I've already seen every single one of these. This continue will get called for every single one, and we'll never actually run this code that adds new things to the next queue. So it works both ways. It's just sometimes if you're doing it that way, it makes a little more sense to go ahead and preemptively check before you put things in the next queue. All right, I think that's all I wanted to cover with this one. I might end up redoing some of it. I'm not 100% thrilled with all the videos and the way I described some of this, but I do want to keep moving on. I also want to mention that, I think I mentioned this in the last video, I am intending on giving a reordering of some of these exercises, or at least giving a guide for beginners and that sort of, people who are a little bit less experienced, a better way to follow the exercises, because right now I don't think they're in the best order. For example, the very next exercise we're about to do is, in my opinion, much simpler than this one. So it's definitely something to keep in mind that if you're watching some of these and getting a little confused, I do plan on getting some exercises that are a little more beginner friendly so that you aren't, just overwhelmed at first.